Hello viewers, in this video I have discussed a few questions of 2020, 2019 and 2018 of numerical analysis of IAS, CSE, UPSC. So please go through the questions, and if you have any query, if you have any point which you want to be explained, please ask in comment section. Thank you. This is a question of 2026B. Here we have to find the solution of the system of equations, and these are the equations. Set up the Gauss-Seidel iterative scheme and iterate 3 times, starting with 3 times we have to iterate, starting with the initial vector x0 is 0. Also find the exact solution and compare with the iterated solutions. So first we will check whether system is diagonally dominant or not. So here we see 4 is greater than 1 plus 1. So from first equation we write the value of x, which comes, if we see the first equation, it is x is equal to 4 minus 5 minus 2z upon 4. From second, y is equal to 7 minus 3x minus z upon 5. From third, z is equal to 3 minus x minus y upon 3, and we write it in the iterative form, where we are writing next iterative value in the form of k plus 1, that is xk plus 1, yk plus 1, zk plus 1, and the previous one is xk, yk, zk. So we have replaced yk and zk here, but as soon as we got xk plus 1, we will be using here in the value of y xk plus 1. In the value of z we will be putting xk plus 1, yk plus 1, because we have obtained these values. So we start from this value, the first equation. We substitute here y as 0, z as 0, because it's an initial value, and calculate x1 because k is 0. For k is equal to 0, this becomes x1 is equal to 1 upon 4, 4 minus y0 minus 2z0. Similarly, y1 will be 1 upon 5 minus 7 minus 3 x1 minus z0, and z1 will be 1 by 3 minus x1 minus y1. We put these values and see what is the result. So here we have written, this comes y0 z0, so 1 upon 4 into 4, which gives us 1, and y1 is 1 upon 5, 7 minus 3 xk plus 1, xk plus 1 is 1, minus z0 is 0, so this comes 1 upon 5 into 4.8. Now z1 is 1 upon 3, 3 minus xk plus 1 is 1, and minus yk plus 1 is 0.8. So we put these values and get the value this much. So now our values for next iteration are these as initial value. So we can say we put k is equal to 1 and we get x2. x2 is 1 upon 4, 4 minus, here it will be y1 minus 2z1. So y1 is 0.8 and z1 is 0.4. After calculation we get 0.6. y2 is 1 by 5, 7 minus 3 into x2. x2 is 0.6 minus z1, that is 0.4. So calculation gives 0.96. z2 is 1 upon 3, 3 minus x1 is x2 we will be using here because xk plus 1, so 0.6 minus yk plus 1, that is y2, that is 0.96, so we get 0.48. One more iteration is required, but we have done two iterations just to see what happens. Then we have calculated the answer, that is exact value, with the help of Gauss elimination, not Seidel. So after getting the answer, that is exact answer, with the help of Gauss elimination, we will compare the result with the Gauss Seidel which we will get here. Now we do the third approximation. Now you know how to do the calculation, as in first x3 is equal to 1 by 4 minus, it will be here y2 and minus 2z2, we get the result. So similarly, as soon as we calculated x3, we will be using it in next iteration, that is y3, and we get the value of y3. As soon as we get y3, we will be using it here, and this is x3 to get the z3. According to question, we have to stop here. Only thing, we have done one more iteration just to see what is the result. But according to, so here I have just written up to 6 iterations. Answer is required up to this much, just to show that how answer is converging towards 0.5, and this will become 1 and 0.5. So we can write the solution as this, but you have to write the solution in the examination this much, which is third iteration. This will be the answer. And now we go for the exact solution, that is Gauss elimination method, and we know how to solve by Gauss elimination method. We will write the augmented matrix, and this is the augmented matrix you see here, and these are the right hand side elements. Now what we do, we have to make this as diagonally, upper diagonally, lower elements we have to make 0, these elements, and if we can make this 1, that will be much better. But for Gauss elimination, that is not required. Gauss-Jordan, that is required. So nothing has been said in the examination, in the question, so you can do as you want to do, whether you can apply Gauss elimination or you can apply Gauss-Jordan method, both will work out. So here we have done this, that R2 minus 3 by 4 R1, it means this is what it says, that we are dividing R1 by 4 and then multiplying by 1 and then subtracting from R2. So this operation, whole operation has been done on R2. So there are many ways, that first you divide it by 4, make it 1, and then make it 0. So steps you can do yourself. Only thing here I have explained. So R3, next element which we have made 0 is this element, and according to this element we have done the calculation, that divided R1 by 4 and subtracted it from R3. So we got this element 0, and on rest of the elements you can do the calculation, same calculation according to the same, means you are using corresponding elements. Then we have made this element as 0. So keep in mind that you are making this element 0, and according to that you do the calculation. So this, there may be many ways to do it, that make this first 1, make this first 1, make this first 1, and then do the back substitution, and without making, you are incorporating in the operation itself but not changing the first row, that will also do. So there are many ways to do it. So we got it, and now we are doing back substitution, and back substitution is from here, that 44 upon 17 z is equal to 22 upon 17, and from here we got z value, which is half, and then we put z value in this equation, that is 17 upon 4y minus 1 by 2 z is equal to 4. From here we get y, and then we do for, so we'll put value of z in this, and then we get 17 upon 4 y is equal to 17 upon 4, which gives us y is equal to 1. And now for first equation, this is the first equation. In this we put y as 1, z as half, and then try to get value of x, which comes half. So the solution is this much. So you can see the decimal values which you obtained in the third iteration and compare them with this result, which is near to this, near to exact. 2019 question 5b, apply Newton-Raphson method to find real root of a transcendental equation, and here it is x log base 10x minus 1.2 f. If we write, so it comes on left hand side, that becomes fx, and correct to 3 decimal points. So important points, we have to find out real root and up to 3 decimal places, and method is Newton-Raphson method. So fx is x log base 10x minus 1.2. Find out f dash x, and then apply the formula xn plus 1 is equal to xn minus fx upon f dash x. There you put the values and then solve the, means calculate the iterations. So here x log base 10x minus 1.2 is equal to 0. We differentiate it. First term is product of two functions x and log base 10x. So we know differentiation of x is 1 and differentiation of log base 10x is 1 upon x log base 10e, and we did this here. As I know its root is 2.74 something, so we took 2.7 initial point and 2.8 the other interval point, and we got this is negative and then this is positive. So it means there is one root lies in this interval, that is 2.7 and 2.8. We find function derivative at 2.7, means in this derivative we substitute x value as 2.7. So this x is cancelled out. So log 10 base 2.7 plus log 10 base e is this much. So we got this value. Now we calculate first iteration, and first iteration is basically, this is the formula, x1 is equal to x0 minus fx0 upon f dash x0. So x0 is 2.7, we have calculated f dash x0 and fx0. So this is fx0 and this is f dash x0. We have taken values. We got 2.74079. Use calculator and get it. Now we will use it as initial value and we'll find out second iteration, and then we will do more iterations if we have to check up to correct to 3 decimal places. So once the two consecutive values are having same values up to 3 decimal places, up to 4 decimal places, because correct to 3, so in fourth rounding of error will be there. So matching is up to, we can do second calculation, second iteration and third. And if you see here, this is coming 2.7031. So in fourth place there is a difference between 740 and this is 3, here 6. So we will be doing one more iteration and we see whether that is same or not. So here it is coming up to this, it is correct. It means correct up to 3 decimal places, because in fourth place there is no change, in fifth is no change. It means correct up to 3 decimal places. So we can stop here, and the root is 19.5b, and here Runge-Kutta method of fourth order we have to apply, and this is the differential equation, ordinary differential equation. Initial condition is given y0 is 1 at x is equal to 0.2, and we have to calculate up to 0.2. It means only one step is required. If we take because h is given 0.2 and x is 0.2, means one iteration is required. So we know fourth order formula. In the formula we will calculate the values and we'll put the values in the final formula, that is y1 is equal to y0 plus k, then y2 is equal to y1 plus k. So in that we will put, so we will see, this is the formula. Y at point 2 we have to find out. x0 is given 0, y0 is given 1, because y at 0 is given 1, so 1 is the value of y0. H is given step size 0.2, k1 is the formula h fx0 y0, x0 is 0 and y0 is 1. We will put this in the equation, because dy upon dx is equal to fxy, and fxy means we have to put in place of x0 0, wherever x is there we will put 0, and wherever y is there we will put 1, so that becomes f01, and calculate that, multiply it by 0.2, you will get 0.2. In the second part, that is k2, is this formula, hf x0 plus h by 2 y0 plus k1 by 2. So k1 we have got 0.2, so here we know x0 is 0 plus 0.2 by 2, that is 0.1, y0 is 1 plus k1 is 0.2 upon 2. Once we put these values, this becomes f.1 and 1.1. So dy upon dx given, which is fxy. It means in that equation we will put x is equal to 0.1 and y is equal to 1.1. We'll calculate that and multiply it by 0.2. You will get this value. Similarly, we will be doing for k3. hf x0 is 0, h is 0.2 by 2, h by 2 is 0.2 by 2, y0 is 1, k2 is, we have calculated 0.19672 by 2. So this comes f of 0.1 and this one. We will put these values, x is equal to 0.1 and y is equal to 1.09836 in dy upon dx. So that is f, and multiplied by 0.2 will get this. Same we will be doing in k4 as I have explained. So k is equal to 1 by 6 k1 plus 2k2 plus 2k3 plus k4. These values we have calculated, put these values here, which we have done here and got the value. Now final formula, y is equal to y1, basically y1, because we are calculating, is equal to y0 plus k. So this becomes this one, 1.196. We have to do this much only. This is for next step. If you want to learn how to do next step, this is here. Otherwise, only thing, what is the change we have done? In place of x0 y0 we have written x1 y1. Suppose it comes that step size is 0.1, then what to do? Then you have to do 2 steps, and in second step you have to write the change will be here x1 we will take y1 and h, and the formula, wherever x0 is there we will replace it by x1, and wherever y0 is there we will replace it by y1, and same procedure. In this we have to draw a flow chart and write a basic algorithm in Fortran C, C++ for evaluating this integral 0 to 6 dx upon 1 plus x square using trapezoidal rule. So we can do that easily if you know any one of that, any language, whether Fortran C or C++. ट्रेपेजॉइडल रूल, इसका फ्लो चार्ट यहाँ पर है. फार्मूला हमें पता है कि डेफिनेट इंटीग्रल को इंटीग्रेट करने के लिए यूज़ किया जाता है. तो स्टार्ट से शुरू किया, फंक्शन को डिफाइन किया जिसे हमें इंटीग्रेट करना है. गेट वैल्यूज़ ऑफ x0 जो कि लोअर लिमिट है, xn अपर लिमिट है, n नंबर ऑफ स्टेप्स हैं. h हमने फाइंड आउट किया xn माइनस x0 अपॉन n से. s इज इक्वल टू y x0 प्लस y xn, मतलब कि ये जो पहले x0 पर वैल्यू फंक्शन की, आखिरी पॉइंट पर फंक्शन की वैल्यू, लूप लगाया i से n-1 तक. सो टोटल पॉइंट्स हैं 0 to n, और ये 1 to n-1 लूप के लिए. s प्लस ट्वाइस ऑफ जितने भी बीच में पॉइंट हैं उन पर फंक्शन की वैल्यू, दैट इज ट्वाइस ऑफ y x0 प्लस आई एच, मतलब i अगर 1 है तो नेक्स्ट पॉइंट हो गया, i अगर 2 है तो नेक्स्ट टू नेक्स्ट पॉइंट हो गया, तो ये सब बीच के पॉइंट्स का ट्वाइस हो गया. एंड लूप और प्रिंट h/2 इंटू एस एज ए सोल्यूशन. तो ये हमारा सोल्यूशन ऑब्टेन हो गया. यहाँ पर प्रोग्राम है, हेडर फाइल इंक्लूड कर ली, फ्लोट वाई, ये फंक्शन जो है y है, फ्लोट है, रियल है, एंड फ्लोट x ये भी रियल है. रिटर्न यहाँ पर हमें किस फंक्शन का इंटीग्रेशन करना है, 1/1 प्लस एक्स स्क्वायर का. मेन हमने लिया फ्लोट x0, लोअर लिमिट x एंड अपर लिमिट h, जो स्टेप साइज है s समेशन को डिनोट कर रहा है. इटरेशन इंटीजर्स हैं, यहाँ इटरेशन तो नहीं होंगे, इंटीजर आई एन, इन्हें हमने इंटीजर बताया, आई को भी और एन को भी, जो नंबर ऑफ स्टेप्स हैं, और आई जो हम इंक्रीमेंट करेंगे, जो कि हमारे स्टेप्स को इंक्रीमेंट करके बताएगा. पुट्स एंटर x0 xn नंबर ऑफ सब इंटरवल्स. सो स्कैन एफ कर लिया, ये हमने x0 xn और n ये नंबर ऑफ सब इंटरवल्स को एंटर कर लिया स्क्रीन से. h इज इक्वल टू xn माइनस x0 अपॉन n, h की वैल्यू आ गई. s हो गया y x0 प्लस y xn. अब हमने लूप लगाया, i इज इक्वल टू 1 टू i इज लेस देन इक्वल टू n माइनस 1, ये इंक्रीमेंट है i का लूप के लिए, एक एक बढ़ता जाएगा. s प्लस इज इक्वल टू 2 स्टार y x0 प्लस i स्टार h. सो वैल्यू ऑफ इंटीग्रल हमने डिफाइन की h/2 star s, and here we get the answer. So we will, in this question we have to convert the numbers in specified number system. So let's start doing. There are 4 parts here. First is integer, 5 to 4 divided by 2, 5 to 4 integer in binary, divide it by 2 till we have quotient as 0, and start writing from this side. So each time we are dividing, so 262, then we are dividing by 2 again, 262 we are dividing by 2 again, then 131 we are dividing by 2, and we keep on doing till we reach to 0, and then we writing in this direction. Bit is helping us in counting the numbers, so we keep on writing bit or digit here, and then we can easily write how many values of 0 are there or 1 are there. And so we got 1, and then from 4 to 8 it means 5 zeros are there, then 1 1 and 2 zeros converted into binary. Here we have to convert this number which is given in binary into decimal, into octal. So what will we do? We will make groups of 3 3 from this side. We'll make group of 3 3 and this, and if nothing is there we'll put 2 zeros after that. So this we have done, all are in 3, so we'll write values of these 3, 2 to the power 0, 2 to the power 1, 2 to the power 2. So first is 2 to the power 0, 2 to the power 1, 2 to the power 2, means 2 to the power 0 is 2, 2 to the power 1 here is into this is 0 plus 2 square is 4, 4 plus 1, 2 to the power 0 is 1, so 4 plus 1 is 5, and then here this is 0, 2 to the power 1 and 2 to the power 2, so 2 plus 4 is 6, 0 and 2 to the power 1 is 2, 2 to the power 0, 2 to the power 1 into 0 plus 2 to the power 2, 4 plus 1, 5. Similarly in this direction, and we write them as we got them in the same order. So it's an octal. Octal means we have taken in the group of 3 digits, so 2 to the power 8 octal we are doing. Here we have to convert this number 5280 in hexadecimal, so divide it by 16, and again we divide quotient by 16. We do it till we reach to 0, and then we write it from this side. And in hexadecimal we know 10 is denoted by A, 11 is denoted by B, and so on. So 1, 4 in place of 10 we write A, and 0 and base 16. So fourth part, in this we have this number which has base 8. So we know it's an octal, so its base is 8 basically, and we have to convert this number into base 10, that is decimal number. So what we do, we multiply each number starting from here before decimal and after decimal. So this is 8 to the power 0 multiplied this number multiplied by 8 to the power 1. This is 8 square into 8 cube. Here this is 8 to the power minus 1, 8 to the power minus 2, 8 to the power minus 3. So we have multiplied them, added them, we got the number which is in here decimal. We have to apply Gauss-Seidel method, iteration method, to solve the following system of equations correct to 3 decimal places. This question is of 15 marks. So we know that in Gauss-Seidel iteration method, system should be diagonally dominant. And here if we see first equation, in this 2 is, which is diagonal element, is not greater than equal to 1 plus 2, we take mod term, so 3. So here we are not fulfilling, so can we interchange the rows? We will see, can we interchange? Here 20 is greater than 2 plus 3, here 20 is greater than 3 plus 1. So in any case it won't happen if we exchange any rows, that it becomes diagonally dominant. If it is not diagonally dominant, we cannot apply this Gauss-Seidel iteration method, so cannot be solved. And this is not point of the examination. As I remember this question, it should be 20 here, then it works well, and this is the question basically. But here, because first row is not diagonally dominant, and after exchanging the rows also we won't get diagonally dominant system, it means we cannot solve it. Here we have to apply Newton's forward difference formula and find the lowest degree polynomial when it is given. So this we can do. We have made the difference table and we are applying Newton's forward, so ui del square ui, we can, what we do here, this is I, and here from next term we are subtracting previous term. In each column same thing has been done, like 25 minus 9, first is 9 minus 1 8, then 25 minus 9 is 16, then 55 minus 25 is 13, 105 minus 50 is 50, 105 minus 55 is 50, and in same manner we have done each column till we reach to 0 constant values and then zeros, and we apply Newton's forward formula. This we know. In terms of generally we write y and p form, so this is y0 generally we write. So instead of p we are writing u minus 1 del u1, u minus 2 del u minus 2 del square u1, and so on. Factorial 2 is 2. Then u minus 1, u minus 2, u minus 3 upon factorial 3 del cube u4. We put these values which are from the upper diagonal. So these values we put of del u, del square u, del cube. So you can see first is u1, which is 1 plus u minus 1 upon factorial 1 into 8 plus u minus 1 u minus 2 upon factorial 2, that is 2 into again 8 plus u minus 1 u minus 2 u minus 3 upon factorial 3 into 6, and next will be 0, so no need to, so we simplify it and we get this polynomial. Here we have to find out question of 2018 5D using Simpson's 1/3 rule. Find the approximate distance traveled in kilometer in 20 minutes from the beginning, and here we are having starting from the rest in the beginning. It means initial velocity is 0 and distance is also 0, because then no time means no speed, 0 time, so it is starting from 0 0. So we can have one more for our calculation, because it is written 0 0, beginning is from rest and speed is in kilometer per hour, and here we have to ask 20 minutes, so we will convert the data in same minute. So kilometer per hour, we will divide it by 60 and we will make it in minutes per kilometers per minute. And let's apply the formula. So here we have the train starts from 0, so integral will be 0 to 20 minutes, and h is 2 bit difference between two consecutive axes 2 minutes. We are having h by 3, and this 60 is due to that we are making this kilometer per hour into kilometer per minutes. So the first value and 4 of odd values, so all odd values, summation of odd values, twice of all even values, and the last term, and then we get this answer. And here we have to write algorithm for solving this equation. X e to the power x minus 1 is equal to 0. This is 2018 5e question. So in the next algorithm the value is different, x e to the power x minus 1 is different, only thing change it and then you can get it. Only thing function value change, rest of the algorithm is same. पहली लाइन है कमेंटेड बाय सेक्शन मेथड, स्टार्टिंग है और ये एंडिंग है. देन इंक्लूड, हैश इंक्लूड मीन्स स्टैंडर्ड इनपुट आउटपुट फाइल की जिस ये हेडर फाइल है. सी और सी प्लस प्लस में काफ़ी सारी लाइब्रेरी फाइल्स हैं जो कि हम इंक्लूड कर रहे हैं, फंक्शन फाइल्स हैं. इंक्लूड मैथ डॉट एच, ये मैथमेटिकल फंक्शंस की फाइल है, ये भी हेडर फाइल है, इसे भी हम इंक्लूड कर रहे हैं. फ्लोट एफ फ्लोट एक्स मीन्स फ्लोट रियल फंक्शन है और इसका वेरिएबल फ्लोट एक्स भी रियल है. रिटर्न करना है फंक्शन को एक्स क्यूब माइनस 4x माइनस 9, जिसका कि हमें रूट निकालना है. ये यहाँ एंड हो गया, सेमी कॉलन. देन ये कर्ली ब्रैकेट्स क्लोज हो गई. वॉइड बाइसेक्ट फंक्शन जो है बाइसेक्टर, जो कि खाली हो सकता है, ज़ीरो वैल्यू हो सकती है, कुछ भी नहीं हो सकता. और यहाँ पर ये फ्लोट एक्स मीन्स ये एक्स जो है पॉइंटर टू फ्लोटिंग नंबर है. फ्लोट ए ये रियल नंबर है, फ्लोट बी ये भी रियल नंबर है, एंड आई टी आर जो है पॉइंटर टू इंटीजर है. देन कर्ली ब्रैकेट स्टार्ट्स स्टार एक्स जो कि पॉइंटर टू फ्लोटिंग नंबर है इज इक्वल टू ए प्लस बी बाई 2. यहाँ एंड हो गया. इटरेशन को इंक्रीज कर दिया 1 वैल्यू से, मतलब इटरेशन आई टी आर प्लस 1 हो गया. आई टी आर इज इक्वल टू आई टी आर प्लस 1 एंड आई टी आर इज पॉइंटर टू इंटीजर है. देन प्रिंट एफ इटरेशन नंबर, ये डी जो है इंटीजर के लिए फॉर्मेट है. परसेंटेज 3D 3 बिट दे रहे हैं. एक्स इज इक्वल टू परसेंटेज 7.5f, मतलब ये रियल नंबर के लिए है जिसमें 7 बिट दी, जिसमें से 5 बिट आफ्टर डेसिमल है एंड देन 2 बिफोर दिस. सो then new line, and this is the pointer to integer, then x pointer to x main function है, then curly bracket starts, integer itr is equal to 0, ये initialize किया, maximum iteration number given, float हैं, ये सब रियल नंबर्स हैं, एक्स ए बी, अलाउड एरर x1, प्रिंट एफ, एंटर द वैल्यू ऑफ ए बी, ये प्रिंट हो जाएगा स्क्रीन पर, अलाउड एरर मैक्सिमम इटरेशन इतना, ये पूरा प्रिंट हो जाएगा, नेक्स्ट लाइन आ जाएगी, ये यहाँ एंड हो गया स्टेटमेंट। स्कैन एफ, स्क्रीन से आप डेटा इनपुट देंगे, परसेंटेज, ये इन्वर्टेड कॉमास आप ध्यान दें कि ये भी हैं यहाँ पर, तो इसको भी देखना है कि ये कहाँ तक है, दिस एंड्स हेयर एंड हेयर, दिस एंड्स हेयर, इन दिस इट इज़ अप टू हेयर। तो जहाँ तक हमें ये फॉर्मेट है परसेंटेज एफ परसेंटेज एफ परसेंटेज एफ, तो ये तीन नंबर जो है रियल नंबर हैं, फ्लोट नंबर, एक नंबर ये डेसिमल, ये जो है इंटीजर है, नॉट डेसिमल, इंटीजर है, यहाँ पर ये इन्वर्टेड कॉमास क्लोज हो गए, एम्परसेंड ए एम्परसेंड बी मीन्स ए फ्लोट है बी फ्लोट है, कॉरस्पॉन्डिंग है, अलाउड एरर रियल फ्लोट नंबर है, मैक्सिमम इटरेशन जो है ये परसेंटेज डी पे है जो कि इंटीजर है, बाइसेक्ट एम्परसेंड एक्स ए बी एम्परसेंड इटरेशन, ये फंक्शन है, डू क्या करना है हमें, डू इफ़ एफ ए इंटू एफ एक्स इज़ लेस देन 0 तो बी को एक्स बना देना है, या एल्स ए इज़ इक्वल टू एक्स हो गया, फिर बाइसेक्ट, फिर हमने कॉल किया फंक्शन एम्परसेंड x1 and a b and itr, so if f absolute x1 minus x, this is the value is less than allowed error, अगर ये है तो print f iteration this is nothing, we won't take this, is equal to percentage 6.4 f, next line, then iteration and x1, so this may be, this is for x1 and here we can have percentage, before this we can have percentage some d iterations हैं, so we can say 3d, and then return 0 curly bracket close, x is equal to x1, then this will be with another one, we can see in all curly black brackets should be closed, this happens, this one loop is here, another loop will be here, another loop will be here, so we can write down this in this manner, one is here, this loop is closed, then we start from here, another loop is closed, start from here, another loop is closed, so all should be closed, x is equal to x1, then while iteration is less than maximum iteration, printf solution does not converge, then iterations not sufficient, it's continuation of this because it's not still closed here, semicolon is here, return 1 and close. So you learn a little bit C, C++ and the meaning of the way we write it. Fortran is much easier than this, is also easier, both are almost same, but Fortran is more easy to understand because that is near to English language, so if you can write in that, that is also available in earlier editions of B.S. Grewal's book, or in other book like Shom series of Fortran, you can find it there. There also programs have been given, in other books also you may find them, so take programs from there or write down or search on net if you want on Fortran. So it's easy and just understand and write yourself. Just Here again we have to change these values, the numbers, into different system. So first is binary to decimal, second is binary to hexadecimal, third is hexadecimal to decimal, fourth is decimal to binary. So as I have explained already, only thing I am giving here the answer, so you can, so this is the first one, but this is first case. How we have done, this is the first part. So here we have done from here to here and multiplied 2 to the power 0, 2 to the power 1, multiplied 2 to the power 2 to the cube, 2 to the power 4, 2 to the power 5, and here multiplied by 2 to the power minus 1, 2 to the power minus 2, 2 to the power minus 3, and get the answer. This is the second part. Here also we have done what this is, we have taken 4 number, actually what we have done, we have to write in this, so we have written binary and which converts into hexa, so 0 1, then binary 10 becomes 2 in hexa, 11 becomes 3, 100 becomes 4, and so on. So this is the procedure. We know that binary, this binary becomes this value in hexadecimal. So we will find what is the value we need to write. So here we see that 2C after decimal places, because this much is 2 and this much is C. 11 is and here 1100 is C, and this is 0010 as 2, and then this 4 times 0 is 0, and then 4 times 1 is F, and then we have 0001 which is 1, and then 1. So we write first binary this number, and we write hex, we can write from here. This method is also inconvenient, you may use another method also. Here we have to convert C4F2 in base 16, and we have to convert into base 10. So only thing we have multiplied as 2 into 16 to the power 0. F in hexadecimal is 15, 15 into 16 to the power 1, 4 into 16 square, and C is 12, 12 into 16 cube, so we get this number. Last part, this was the third and this is the fourth. So this was third. So here we have divided 418 by 2, and quotient is 209, and again we divide quotient till we reach to quotient as 0, and we write from here this number, and we get